this video, we are going to be looking at the change of base formula, which is the very last page of the A-16 notes. And this is primarily for period 5 because we didn't get to this, but certainly for anybody who wants to kind of see this again. All right, so the change of base formula, the reason for it is because if you have a base other than 10 or e, like if I had log base 4 of, I don't know, 19 or something like that, and I wanted to know what that value is with an approximate value. Back in the old days, before there were calculators, graphing calculators or even calculators at all, you wouldn't be able to do this really by, you wouldn't be able to do it without a calculator. So what we had is we had tables of values that gave logs in base 10 or logs of base e. So we had tables of values for those. We couldn't have a table for every log of every base. So what they had instead was they had a formula that you could use to change this into one of these bases, and then you could use the tables of values to look things up. So that's basically why we need this change of base formula, but it still comes up every once in a while in the work that we're doing. Okay, so the way that the change of base formula works, first of all, you'll notice that we have an expression here that's log base b of a. We say that a and b both have to be greater than 0 because we know that the base of an exponential has to be greater than 0. You can't take the log of a negative number or 0, so that has to be greater than 0. And what we're going to do, you'll notice that they also throw in a c. So the c is going to be the base that you want to change your answer to, right? And that also, because it's a base of a logarithm, has to be greater than 0. So the way that this formula works is it says that if you want the log base b of a and you decide I want to change it to log base whatever, all right, suppose I said I want to change this to log base 7, all right, so I want this to be in terms of log base 7, how would I do that? So you have your base that you've chosen. Sorry, I'm just going to go back to this one. You have your base that you've chosen. This is not the same sheet. Which is going to be c. So we're going to do the log base c of a divided by the log base c of b. So notice that the c that you have here is your chosen base. I don't know why this keeps freezing on me. Okay, the c is going to be your chosen base, and then the a that's here comes from here, and the b that's on the bottom comes from the base that's here. So there are a couple special cases of this because, like I said, most of the time if you had, log base 4 of 7, which I think is the example I used just a minute ago, you would want to change it into log base 10 or log base e. So if you want to change it into log base 10, if you have log base b of a, then all you have to do is let c equal 10. And so when I substitute that in here, I get log base 10 of a divided by log base 10 of b. And remember, log base 10 is just the same as log. So log A over log B. All right. Now, if I want to change it to log base E, ln, then remember that would look like this. It would be, and now I'm putting C is equal to E. So I'm putting E in here for each of these. So I get log base E of A divided by log base E of B. And that's just the same as ln of A divided by ln of B. So basically, we're being told that these are equivalent to each other. We saw some problems like this the other day where you had the same numbers, top and bottom, but this one was log and this one was ln, and we found out with the decimals we got exactly the same answer. So a proof of this first. So a proof is we are starting with log base b of a. So this is sort of our given, log base b of a. Right? And what we're going to do is we're just going to set that equal to something because that's what we want to know. What is this equal? So I'm going to set it equal to y. So we're going to let log base b of a equal y. So I can change that to exponential form. So exponential form will be the base of b. I'm going to swing over here and pick up the b exponent. The y is the logarithm, so that's the exponent. So b to the y equals a. Okay, so now we want to resolve for a. I know this might seem a little bit silly, like, I'm sorry, not for a, but for y. You might say, well, we were already solved for y, right? I put it in exponential form, and now I want to solve for y again. Well, that's because this is where we introduce the other logarithm. So if I'm going to solve this exponential equation, I'm going to take the log of both sides, And remember, you can take the log base whatever you want. So I'm going to take the log base c of both sides. So again, as long as c is greater than 0, it doesn't matter what it is. And so now if I bring the y in front, I get y times log base c of b is equal to log base c of a. And then if I want to solve for y, because that's what I want to know, what is log base b of a equal to? So I'm going to divide by log base c of b. And so you can see these cancel out, so we're left with y equals log base c of a divided by log base c of b. And you can see that'll match what is right up here. Okay? All right, so now, example 1, we're going to take a specific problem, log base 2 of 9, and we want to find the approximate value of this. It says to 3 sig figs. And we're going to use the change of base formula. And I'm just pointing out that in your homework, it doesn't really specify when you do these problems that you're supposed to use the change of base formula. I think it just says find the value of this. I want you to use the change of base formula. That's what this lesson was all about. And it says it in the instructions. So make sure you're using the change of base formula. So we want to change this to log base 10. So if I have log base 2 of 9, right, then remember up here, we're using this formula. We want the log of a, which is this number right here, divided by the log of b, which is here. So this is going to turn into the log of 9 divided by the log of 2. And you can type that into your calculator. You're going to get 3.1699 and so forth, which is approximately 3.17. Okay? If we want log base e, again, it's this log base 2 of 9 that I want to change into base e. So I'm going to take the natural log of 9 over the natural log of 2. That's using, again, this formula right here. So now when you work that one out, you should get the same thing. 3.1699, blah, 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 which rounds to about 3.17. Okay? The last one is similar to problems that you've done before. So this says the log base 4 of 7 is p, the log base 4 of 9 is q, and we want the log base 7 of 9. So what you should recognize, I'm going to call this part A. We want to write this in terms of p and q, because I'm going to do a part B also. So part A, we have the log base 4 of, we want to find the log base 7 of 9. So if I use the change of base formula, what base would I change it to? Well, how about 4, because that's what the rest of this problem is about. So I'm going to end up with the log base 4 of 9 divided by the log base 4 of 7. All right, then you should be able to look at this and see, oh yeah, log base 4 of 9 is right here, that's just q. And log base 4 of 7, that's right here, that's just p. So there's your final answer, q divided by p. For B, let's look at the log base 7 of 81. All right, so if you remember these problems we did before, you want to use the 7 and the 9, and then also the base, which in this case is 4, to help you out with writing something. All right, so you might notice that this is actually 9 squared, and we can hold off on that for just a minute. But just notice with the change of base formula, if I want to change it to base 4, that this becomes the log base 4 of 81 divided by the log base 4 of 7. Now, up on the top, we have log base 4 of 9, but 81 is 9 squared. So this is really log base 4 of 9 squared divided by log base 4 of 7. I have the log of a power, so I can bring that in front. So I get 2 times the log base 4 of 9 divided by the log base 4 of 7. So the 9, log base 4 of 9, that's the q. And log base 4 of 7 right here, that's the p. So 2q over p for that one.